Assalamualaikum. In this video, I'm going to continue an example of DOE. So, look at this example 1. Okay, so here we have only one vector, which is the type of textbooks. We have two types, text 1, textbook type 1, and textbook type 2. And then so from this given example, the response is the student marks. So means that by using the textbook 1, so what is the marks for the student? Okay. So and then textbook 2, what is the score for the student? And then we have the average marks for the textbook 1 and average for textbook 2. So from this example, we can identify the number of levels. So since we only have one factor, so we just refer to the textbook level. So we have two levels. Okay, so it means that type of the textbook is the level of the factor. So it means that our A, which is represent the number of level, is equal to. And then replicates. It means that the number of observation in each run. So because we have only one factor here, so our run we only have two run. Okay, referring to the level of the factor. So for each level we have 3 observation here. So means that our replicate is equal to 3. So replicates represent by n. So the number of n is 3. So you can see here there are 3 scores for text 1 and 3 scores for text 2. So n equal to 3. And then run equal to r, we represent as r. So run referring to the level of the factor. So we only have 2 levels or 2 types of the textbooks. So that is why our run is equal to 2. Next example, there are 2 factors, which is factor A and factor B. So factor A is the textbook, and now we have another factor, which is the studying hours. So represented by B, okay, factor B. So we combine these 2 factors according to their level. So just now we have 2 types of textbooks, and then we have the studying hours of the students, which is 1 hour, 2 hours, and 3 hours. So for each level, here or each run here, the combination of the level for each factor, we call it run. So we have 6 run here. So the R is equal to 6. So 1, 2, 3, 4, 5, 6. Okay, so means that the combination for each level of the factor. So there are 6 combination, 6 run, call it. And then for each run, we have 2 observations. For example, for 1 hour studying, and then by using the textbook 1, there are 2 observation marks here. So means that there are 2 replicates for each level of the combination of each level, which where we call it run. So for each run, we have 2 observations. So that is what we call it replicates. So replicates equal to 2. So you can see here there are 2 observations for each run. Then A and B here referring to the level of each factor. So factor A, which is the textbook, we have 2 types here. So that is why the level is 2. And then for type B factor, B factor, we have 3 level, 1, 2, 3 in hours, referring to hours. So that is why the B is equal to 3. So that is how we define the item in DOE. So this is just a continue of the importance of DOE or the objective of DOE. So from the example, the 2 examples previously, so we can see that there are several factors, and also we can have only one factor. So from that, we can determine which factor are most influential. So means that if we have several factors, we can know, or we can determine which one is the most influential on the response, which is the Y. Okay, so which one gives most impact or effect to the Y. And then we can determine where to set the level of the influential or the factors, so that the response or the Y, okay, is near to the desired requirement, and also we can decrease the variability in Y. So variability, if we can decrease, is good. So we can set the level of the factor to achieve such objectives. Okay, so for a single factor experiment, so single factor experiment can be used in the situation where the effect or the influence of a single factor on the response is dominant. So it means that it will give a really significant impact to the observation or the response. So that is why we have single factor. So from the single factor, we have several levels. So we want to know how is the effect when we control the level of the factor. So this experiment of single factor will be useful because we can easily control the factor, and then we can see how to set the level of the factor. So we can proceed with several factors. So we run the simple test first, and then we proceed with more complicated tests which involve more than one factors. Okay, let's look at this another example. We have only one factor, which is the heartbeat concentration. Okay, so we have 5 levels, so for 5 to 20%. So for each level, we have 6 observations. So means that we have 6 replicates. Then from the observation or the output, we take average of each level of the heartbeat concentration. So if we total up the number of observation, there are 6 times 4. Okay, 6 replicate times the 4 levels. So we have 24 in total. Okay, 24 observation. So you can see here, okay, we extract the information from the table just now. So how many replicates, how many observation in total, then level. Okay, so we have 24 observations. So in this example, we want to show you that even we have the different level of percentage of the heartbeat concentration. So for each level or percent, we have 6 observation, but when conducting the experiment, we are not taking the or do the experiment in by level, means that we are not finish all the 6 observation for the first level, and then we move to the second one and third one and last percentage. But now we want to randomize the level of the percentage. So while you are doing that, that is what we call actually the randomization in taking observation. So we can refer to the previous video where there are one topic on this one. Okay, so it means that you have to know why we randomize the observation. Okay, so this the subscript number for each observation. Okay, for example 12, 4, 7. Okay, subscript number there represent the number of observations. For example, 7 here is the first observation, second observation, third observation. So we are not doing that way. Instead, we put it as a random. So we can generate a number of random number by using Excel, for example. Then we test according to the different level from the randomized number. Okay. So for this example, okay, so we're not taking the first observation, okay, but this is the 12th observation actually. Okay, means that the first one will be in here 17. So this is the first observation, means that we start with the 10% first, and then second observation, which is this one 11, okay, which is at 5%. So we randomize the percentage actually, but in order to doing that, we have denote the number of the observation, okay, where we want to order in a random way. So we test it in a different percentage, not according to the level of each level. We are not finishing the first level and then we move to the second level. So we are not doing that way. So why are we doing that? Okay, so there are reason, it is desire to apply the randomization in observation from different level. So it is to balance out the effect of any nuisance variable. So for example, in taking or when we perform the experiment, we involve with machine. So the machine has the warm up effect. So it means that the last observation means that the heat is higher compared with the first observation. Means that when we randomize, so we balance out the effect of the heat up of the machine. So that is very important actually. Okay, then from the output or the observation, we can plot a graph to this example. So the paper strength is in the y-axis, and then the hardwood concentration percentage is in the x-axis. So we can plot the graph. So from this graph, we can see that when the hardwood concentration is increasing, the paper strength also increasing. But we can see that it keep on increasing. But when up to 30%, it looks like more constant. So means that there is no reason to increase the percentage up to 50 because there is no effect anymore to the paper strength. So we can stop up to 50. So from this graph, we can see the effect. So that is why it is important to control the level of the effector. So we can see the effect of the level. Okay, so because this one you can control them, the level of the concentration. So we can see the effect. So the increasing and then it is slowly increasing. So it stop increasing up to 50. So we can control and then we can optimize the process. Okay, let's look at another example here. Okay, this is the general data table for a single factor. So afterwards you can know how to read the data, because we have the notation for each observation. For example, okay, so for this one, we only have a single factor, and then there are different levels, so we do as A. So first level up to A. Okay, so for the subscript here, okay, means that 1, 1 represents the first observation of the first level. And then 1, 2 represent the first level for the second observation, and so on. So we have n replicates of the level 1. So we will do for the same thing. Okay, so for each level, we have n replicates. So this one should be n. So then we have here the total. So 1 dot y 1 dot means the total for the first level. And then we have the average. So supposedly this one is a bar. This one is a bar. So means that the average. Okay? Average of the first level, average for the second level, and so on up to the A level. So A dot y bar here, y bar. So referring to the A level. So this is the average. And then we have the total, in total, okay, for all level. And then we have the average for all observations. So y bar dot dot. Okay, so this represents the average in all observations here. Okay, so we have to get use of this notation. Okay, so this is the formula. Okay, for the first total of the observation, I level. So for example, I level. So if I referring to the first level, so y1 dot. Okay, so we total up the observation for the first level just now. So this one, okay, for this is the total for the first level. So means that this is the formula. Okay, up to n. So n is the number of replicate. And then we have the average. So this one is the total. And then we have the average of the each level. So we divide by the number of replicates. So n is the replicate. So for each level, we have the average. And then we have the grand total of all observation, y dot dot just now. And then we have the grand average of all observations. So we can see that this one is equal to the total divide by capital N, means that the total number of observation. So means that we average out all the observation in order to get this. Okay, so N is the number of observation. So because it is just one factor, just single factor, so the N is A multiplied by N. Okay, so because A is referring to the level of the factor, because now we have one factor. Okay, we move to the next topic, which is the analysis of variance and also known as ANOVA. So ANOVA is the analysis of variance. So it is important statistic tool used in both POE. So in this analysis of variance, actually we want to test or decide which factors have significant effect to the response, whether the factors has equally, means that no difference effect on the response, or there are significant difference. Okay, so this is the general model of ANOVA. So you have to know the notation here. So previously we already know about y bar dot dot. So y bar dot dot here we can represent as mu. Okay, so mean of this model. Okay, mean taking from the Yij. So Yij is the response just now, or the observation. Okay, so the model here we can write as mu plus tau I. Okay, so tau is the eye level effect. So for each level it has effect. Okay, its own effect for each level. And then we have the random error. Okay, so here this one, these two can be represented as mu I, or it also equal to, or approximately equal to y I dot. So level 1, for example, y mu 1. Okay, so for the the average of the first level is approximately equal to y1, because the first level dot bar. Okay, so means that the mean for the first level is approximately equal to the observation of the first level. Okay, the average of the first level. Okay, so whereby we denote just now y bar 1 dot. Okay. So then, because this one is equal to mu y, so we can simplify this equation by using the mu I. So mu I is plus the epsilon here, which is the random error. So we get the observation Yij. We refer to the example of this process capability by using two types of machine. So there is only one factor, which is the machine. We have two types, which is we say as the level of the machine. Okay, so USA and Japan. So it is qualitative factor. Okay. So A, the level of the factor, so equal to 2, and then for each level we have 3 observations, so means that the replicates is equal to 3, and then the total number of observation is capital N, so A times N, so 6. Okay, so all we have in total 6 observation. So from this output we can find or calculate the mean. Okay, so this is the total y1 dot here, the first level total. So this is the observation for the first level. So means that we're taking the total of this observation, the 3 observation here, and then we take the average. So y bar 1 dot means that the total divided by the number of observation of, or the replicate of the observation, the first level. So this is the average for the first level, and then this is the average of the second level. And then we have the total of the overall observation, and then we have the average of the total observation. And then it is approximately for the mean, referring to the ANOVA model just now. And then we can see the effect for each level. So for tau 1, which is represent the effect of the first level, so we can calculate by taking the difference between the first level mean and the average of the first level and the average of the total. Okay, so here is the first level 2, and then we minus with the average in total. Okay, so total average of the observation. So the effect of the first level is 0.5. And then the same thing for the second level, which is referring to the second type. Okay, so which is for the Japan, the second type, second level. Okay, so it is negative 0.5. So this is the effect of the level. And then we calculate the error. So what is the error? Okay, so random error actually. So the first observation, we find the error for the first observation. So this is the first observation, ij for example, and then we minus the mean of the level. Okay, so we find the error for each observation. Okay, for the first level, the mean is 2. Okay, mean 1 is 2, or the y bar 1 dot. Okay, for the first level, the mean is 2, and then we can find the error for the first observation. So the first observation here, so y1 minus y bar 1 dot. Okay, so means that 0.1 minus the mean. So the mean is 2. We get 0.1 for the first error of the first observation. So 0.1. So we proceed for the second observation and so on until all the observation is calculated. Then we put in the table of the error. Okay, so we have 6 errors representing each error of the observation. And from what we have just calculated just now, okay, we can visualize how we get the observation. Okay, so instead, for example, for the first observation whereby the value is 2.1, what is contribute to this 2.1 actually? So we can know by using all that we have calculated just now. Okay, so the first one is the mean in overall. So it contribute 1.5. Okay, so this is all 1.5. Okay. And then next contribution is the effect of the level. Okay, so the first tau 1 here referring the effect of the first level, because the first observation referring to the first observation of the first level. So means that plus 0.5, because tau 1 just now we have already calculated, it is 0.1. And then another one contribute to the observation is error. Okay, so error 1 just now is 0.1. So 1.5 plus 0.5 plus 0.1, we get the value of the first observation. So this is how we visualize for each observation. So what are the items contribute to the observation? And then another thing we can visualize is the effect of each level. So means that here, for example, we have 4 levels. Okay, tau 1 referring for the effect of the first level, tau 2 for the second level, and until tau 4. So there are 4 level effect. So from the effect of different level, so we calculate the mean in overall. Okay, so mu, okay, we present as mu. So we can see that in this figure, instead all the effect of the different level give the same effect for the overall mean. That is why the mean is in the middle. So all you can see here, the effect or the length of value, okay, is equal. It is similar effect. So all the 4 factors level, 4 level of the factor give the same effect for the overall mean or average. Okay, next example, you can see here for the first figure. Okay, tau 4 has a greater effect if we compare with the first, second and third level effect. So now we can see it is more significant effect to compare with other. So this is the mean in overall, the mean here. Okay, so means that tau 4 contribute the most. Okay, so for the first, second figure here, okay, so the mean overall is in here. So the mu1 here, the tau 1 gives the most effect, okay, compare with other level. So what are the difference between these two figures we need to show us? So we previously know that the tau I is equal to mu I minus mu. Okay, and then for this example, okay, first figure shows here, so means that tau 4 equal to mu 4 minus mu. Okay, so mu 4 is this one minus mu. So we can see that this mu 4 is less than mu because it is on the lower part of the mu, right? So means that mu 4 is less than mu. So then if mu 4 minus mu, we will get negative number. So means that the tau 4 is negative number, means that it gives negative effect for the mean, overall mean. Okay, so this one, it is positive because this mean 1 is greater than mu. Okay, means that it gives positive effect on the overall mean. Okay, back to the ANOVA. So ANOVA is a test of variance. So what we are going to test? Okay, we are going to test if a factor has effect on the response. Okay, so this is how we construct the hypothesis. So we already learned the hypothesis testing in the previous chapter. So we're going to apply the same knowledge but in a different scope or different application. So now it is on DOE. So what we are going to test, it is regarding or involving different mean. Okay, so basically in previous chapter we want to test whether mu1 equal to mu2 or mu1 is greater than mu2. So it only involves testing of two means of operation. But now we can have more than two. Okay, this is called ANOVA. So the first one, as usual, we already learned the step-by-step in hypothesis testing. We have to state the hypothesis. Okay, so the hypothesis is all the mean is equal and it equal to the mean overall. So this also can be represented by taking the different. Okay, so this one is previous chapter, so we can take different, right? So means that mu1 minus mu2 is greater than 0. If we want to test on the right tail test. Okay, so now we want to test whether it has different or not. So we take the different for each mean and then means that the difference is equal because all the mean value is equal. So when we minus the same thing, so we get 0. So the same thing goes for the effect of each level because this will represent the tau. Okay, the first level effect. And so until level A. So the same thing, it is equal to 0. Means that all the effect is equal to 0. So means that this is our null hypothesis. So if the factor has effect, the value of response will be different along with the change of the factor. So means that the factor gives significant effect on the response. And then the more the response differs, the greater the effect of the factor is. So that is what we're going to test. Okay, so we state the null hypothesis, okay, by using the tau just now, the effect of each level. And then the alternative hypothesis, the tau is not equal to 0 for at least one level. Okay, so means that we want to test whether if this all factors level give the same effect or it is not significant, is it? Okay, And then the alternative is there is one level that is not equal to 0. This is the null and alternative hypothesis. So as usual in hypothesis testing, we might have the wrong decision. So we have two types of error. The first one is the null hypothesis, which is the not is rejected when it is actually true. So this is the same principle what we have learned in the previous chapter. So means that it is true. So means that the statement or the claim is true. So means that the null hypothesis here actually true, but we reject the hypothesis. So means that we make the first type error. So for the second type error, the null hypothesis is accepted when it is actually false. Means that we should reject the null hypothesis because it is false. But now we accept that. Okay, so we have made a wrong decision. So that is type 2 error. It is false, but we accept the statement of the null hypothesis. Or in other way, for DOE, it means that the factor is concluded ineffective. Instead, we say there is no effect because it is 0, but actually it is effective. So we have made the wrong decision on conclusion. Okay, let's look at this example. Okay, we have different type of machine. So one factor of 2 level, which is USA and Japan type of machine. And then we have 3 replicates for each line. Okay, so we calculate the mean for the first level, it is equal to 1.5, and then for the second level, it is 1.5. And then, so the same thing, okay, the same value for each level. And then we calculate the tau, which is the effect of the level. So means that in overall, it's all, of course, it is 1.5 because the mean for each level is also 1.5. So when we want to calculate the effect of each level, so the first level means that mean of the first level minus the mean overall. So we get 0. So the same thing for the second level. So means that both tau is equal to 0. So we can conclude that the factor, which is the machine, has no effect on the process capability because both give 0 effect. Means that doesn't matter which machine we use, so the same result will happen. So if we want to represent the tau and the mean just now, visualize. Okay, so we can see that the minor variation is caused by the error rather than the machine, because we can see that of course the observation here is a different value, but when we're taking the average, actually it is the same. So means that it does not have effect. So the variation just means that it gives the variation in terms of the error, not the machine itself. Okay, so instead there is no effect. Okay, then I stop here. We will continue in the next video, inshallah. Okay, bye. Assalamualaikum.